We tend to think of logic as, well, rock solid, right? It's supposed to be the one thing in the universe that's totally fixed, a set of unbreakable rules for how reason itself works. But what if I told you that about 100 years ago, a single mind-bending riddle brought that entire system to its knees and forced us to rewrite the very definition of truth?
I know, it sounds completely nuts. How could one little slip-up prove something so ridiculous? But for over 2,000 years, the entire fortress of Western thought, from philosophy all the way to math, was built with one core mission: to stop that exact kind of catastrophic failure. Because as you're about to see, in classical logic, that's precisely what a single contradiction does. So, to really get how logic broke, we first have to appreciate just how perfectly it was built. For millennia, it stood on this one powerful and what seemed like a totally obvious foundation.
And this is it, the big one, the law of non-contradiction. Championed by guys like Aristotle back in ancient Greece, this was seen as the absolute cornerstone of all rational thought. It's the simple idea that a thing can't be both itself and its opposite at the same time. A statement can't be both true and false. Seems simple, right? But oh boy, the implications are massive.
Because you've got to understand, in this system, a contradiction isn't just a flaw in your argument. It's not a minor error you can just fix and move on from. No, it's a detonation sequence for the entire system of reason. Once you let a single contradiction inside the gates, it doesn't just damage the fortress, it levels it completely.
And this is where the real danger is. It's called the principle of explosion. That Latin phrase there, ex falso sequitur quod libet, literally means from a falsehood, anything follows. If you can prove just one thing is both true and false, you can then logically prove anything: that the sky is green, that you can fly, and yep, that the moon is made of cheese. This isn't a bug, it's a feature. It's the system's self-destruct button, designed to keep contradictions out at all costs.
And for 2,000 years, this system worked like a charm. The fortress stood strong all the way from the ancient Greeks through the Middle Ages, right up to the turn of the 20th century. By then, mathematicians and philosophers really believed they were on the verge of creating a perfect, complete system of logic. They thought they were this close to having it all figured out.
But you know how these stories go. Right at that moment of peak confidence, a few thinkers who are messing around with new ideas, like infinity and sets, well, they found a tiny crack in the fortress wall. A crack that was about to bring the whole thing crashing down.
This right here is a version of what we now call Russell's paradox, named after the philosopher Bertrand Russell. It's a deceptively simple question that classical logic was completely unable to answer without destroying itself. And this was devastating because at the time, mathematicians were trying to build all of mathematics from the ground up using the simple idea of sets. This little paradox showed their most basic building block was completely broken. Let's walk through why. You see the trap, right? It's a perfect, inescapable loop. If you say yes, the answer has to be no. But if you say no, the answer has to be yes. You are forced into a conclusion where the statement is both true and false at the same time. The law of non-contradiction is shattered. And in the pristine, perfect world of mathematics, this wasn't just some weird little puzzle, it was an absolute catastrophe.
And if that was the first major crack, the final knockout punch came a few decades later from a logician named Gödel. He delivered it with his two incompleteness theorems. He proved, with this devastating certainty, that any logical system that was powerful enough to do basic math would always have statements inside it that were true, but that could never be proven true using that system's own rules. The fortress wasn't just cracked, it was fundamentally, inescapably incomplete.
And this wasn't just some academic puzzle, it was a full-blown crisis. Gödel's work basically showed that the dream of a perfect, complete, and consistent system for all of mathematics was impossible. The foundation was unstable. Because if their system had a paradox hidden in it, and that paradox triggered the principle of explosion, then all of mathematics was completely meaningless. Logic had broken itself. So what do you do? What do you do when the foundational tools you use to figure out what's true are themselves broken? Well, you don't just give up on reason. You get creative. You invent new tools. In the aftermath of all this, thinkers basically went down two main paths. Each one had a radically different strategy for dealing with paradoxes. One group wanted to rebuild the fortress walls but make them even stronger. The other group decided to just go in and disarm the bomb.
So the first path was called intuitionism. These guys were super cautious. They argued that the whole problem started because we were accepting these abstract statements as true without actually being able to build a proof for them. For an intuitionist, truth means provable. You can't just claim something exists, you have to show me the recipe for how to build it step by step.
Now this is a complete game changer. See, classical logic lives by the law of the excluded middle. Every single statement has to be either true or false, no in-between. Intuitionism just throws that out. It allows for a third state, a kind of uncertainty zone, until a proof is actually constructed.
Okay, so the second path, paraconsistent logic, was way more radical. It was super pragmatic. Its supporters looked at that self-destruct mechanism, the principle of explosion, and they asked a really simple question. Hey, what if we just turn it off? What if we build a logic that can handle a contradiction in one little area without letting it infect and destroy the whole system?
And it turns out this is incredibly useful for the real world, because the real world is messy. Paraconsistent logics are perfect for these kinds of situations. Think about an AI or a robot that gets conflicting data from two different sensors. Instead of just crashing, it can use paraconsistent logic to say, okay, I have a contradiction here, and just keep on functioning. It's also vital for managing huge databases where you're bound to have conflicting information. This logic lets a system stay robust and keep reasoning, even with a few paradoxes rattling around inside.
So what this crisis ultimately led to was a whole new landscape for reason itself, one that was way richer and more diverse than that old, rigid fortress.
The Great Crisis didn't destroy logic. It forced it to evolve. We went from having one single rigid black and white system of logic to having a whole toolkit of specialized, colored logics, each one designed for a different purpose. And here's the key takeaway. Right here on this chart, you can see exactly how these new logics were built. Classical logic needs all three of these principles to hold. But intuitionistic logic says, you know what? We can reject the law of the excluded middle. And paraconsistent logic says, we'll reject the principle of explosion. Each one is a different tool, created just by changing one of the fundamental rules.
The story of logic's crisis and rebirth really shows us something profound. Even our most fundamental systems for understanding the world, they aren't fixed laws of the universe. They're creative, evolving human inventions. They're tools we design and redesign to meet new challenges. And it just makes you wonder, right? What other absolute truths are we living by today that are just waiting for the right paradox to come along and change everything?